have a rod of mass m and length L. The linear mass density is constant. It is non-varying. Right now it is in a vertical position. This is frictionless pin jointed over here so that this can easily freely move. So one thing we understand is that is when it falls gradually, continuously, its angular velocity will be increasing. That is, it will have some alpha. That is, it is not a case of uniform circular motion, but alpha is going to be there. That means it is going to be a case of non-uniform circular motion. That is, angular velocity will be increasing. If this is non-uniform circular motion, we know in non-uniform circular motion we have two acceleration. One is centripetal acceleration, the other is tangential acceleration. So we have a centripetal and we have a tangential, right? How do we get a centripetal acceleration? These two things really required over here. How that is required over here? Let's come to that. Center of mass is over here and now its center of mass is over here. So it has gone from here to here. When this point has gone from here to here, the CG has gone from here to here. Center of mass is that point where whole mass is supposed to be concentrated. So initially its CG was here or center of mass was here and now it is here. If it had gone by theta, so this is the loss of height. This is the loss of height. This we can calculate. Total is L, so this is half is L by 2. So this is also L by 2. So if this is L by 2, so here to here is L by 2 cos theta. So this H is L minus L by 2 cos theta. This minus this is equal to loss of H. So from here we can say, to find centripetal acceleration, we can say mg h. H is what? H is L minus L by 2 cos theta. This potential is lost. Where it goes, this is a pure rotation about point P, is equal to about P, that is half I about P omega square. So from here we can get mgl 1 minus 1 by 2 cos theta is equal to half. We have to find IP about this. About the center of mass, it is ml square by 12 plus about this m L by 2 square. We have used parallax theorem, half I omega square. That is the loss of potential energy by the center of mass mgh. H is the distance through which it has fallen, center of mass has fallen. Where it goes, half I omega square, that is rotational kinetic energy of this rod which is rotating about the point P. So half I omega square. I is about this axis. We know about I about ICM. Center of mass is ml square by 12. This is L by 2. So I about this is ml square by 12 plus m into L by 2 square. We have used parallax theorem. So from here, when we know omega, the centripetal acceleration of this point is going to be r omega square. That is AC is going to be r omega square, where r is what? R is L by 2. So AC is equal to L by 2 omega square. So from here we can calculate AC. AC is calculated. One part is done. Now let's go to finding A tangential. So when it has fallen through this angle theta, right now about this point P we take the torque. Mg is acting over here at the center of mass. This is L by 2. This is L by 2 cos theta. So this is L by 2 sin theta. AC we had found r omega square. We have found the value, that is L by 2 omega square. Omega we have found using the energy conservation principle. Now we are talking about the A tangential. For A tangential we know that is A tangential is equal to R alpha. So we need to find alpha. From where we can find alpha? Torque is equal to I alpha. Probably from here we will get it. We will put alpha over here and from there we can find the A tangential. So mg into L by 2, mg into L by 2 sin theta is torque. Torque is equal to I into alpha. I about what? I about P only. That is I P into alpha. So mg into L by 2 sin theta is equal to IP about this. Once again we can use parallax theorem. That is ml square by 12 plus m into L by 2 square into alpha. We get the value of alpha from here. We can get the value of alpha. So it means once the value of alpha is known, so it means at this instant the tangential acceleration of this is going to be equal to r into alpha. That is AT we know. AT is equal to r alpha. So acceleration of this is equal to what? AT is going to be equal to L by 2 into alpha. Alpha we have calculated over there in terms of ml, etc., sin theta, etc. it will come. So now we have centripetal acceleration also and we have a tangential acceleration also. Now what to do of these two accelerations?